The second example is 7.2. This is the hardest of the three examples. A plane has an airspeed of 185 miles per hour and a heading of 120 degrees from due north. The wind currents are running at a constant of 32 miles per hour at 165 clockwise from due north. Find the true course and the ground speed of the plane. So the hardest portion of this problem is to actually picture to see what is going on in here. I know that the airspeed is 165 miles per hour with a heading of 120 degrees. So from north, I know it's 120 degrees clockwise direction because this is how heading works. So this is my 120 degrees and 185 miles per hour. So let's start here. Now the wind currents are running at a constant of 32 miles per hour at 165. So it's this way, right about here. This is 32 miles per hour. What's going to happen is instead of going the course that it's supposed to go, the plane will actually shift going that way because of the current of the air. So what happens is I create this 32 over here, and this would be my 185. I am creating a parallelogram, but the actual course would be from this point down to this one. Now this is what I'll label X because that's what I need to find. Now the picture will start looking messy right about now, so what I'm going to do is I'm going to redraw it over here. I have my 185 miles per hour. I have the 32, and this is what I'm looking for. This is my X. I do need to get some angles in there. I know that this piece is 120. All the way over here is 165. That's part of my problem. So the difference between 165 and 120 would be my 45 degrees. Also, I know the difference between 120 and 180 is 60. So I have a couple of things going on in here. I know that this green angle is going to be 60 degrees. I also know that this little angle, I'm going to label it as red, this little guy right here, it's not coming up. There it is. That little guy has to be 165 subtracted from 180. That's only 15 degrees. That's why it's so little. And I also know that the difference between 60 and 15 is 45 degrees. So that's the other part of my red. So that's 45 degrees. I also know that since this whole piece is 45 degrees, I'm using, again, so these are two parallel lines. Again, I know that these are alternate interior angles, so I know that this is 45 degrees. Now this is the most important piece of information as of right now, because if this is 45 degrees, I also know that this is 135, and I have my angle right there. At this point, I notice I have side, angle, side, I'm in the perfect scenario for law of cosines. The setup is then very easy once you figure out what is going on with the picture. So the x squared has to be 185 squared plus 32 squared minus, you take the 185, no, you need the 2 times 185 times 32 times the cosine of the 135, the angle that's opposite of the x. I'm sorry, this is 185 squared, 32 squared, then you take the 2 times the b times the c, and then the cosine of the angle that's opposite of the x. Once you plug all of this in the calculator, you will get x squared to be 43,621. You take a square root of that, you'll get 210 miles per hour approximately. Now this gives me this 200 miles per hour. So I know that this is 210, I know this is 185, I know this is 32. I also need to know the true course. The true course would be, and at this point the picture is super messy, is the blue piece right here. It's the actual angle at which the plane is flying. So it's this guy right here. I'll call it theta, and in order to find it, I need law of sines. So sine of theta is opposite of 32, and then we already found the 210, so I have sine of 135 degrees divided by 210. That would give me the proportion of finding the theta. So sine of theta has to be 32 times sine of 135 degrees divided by 210. So theta came out to be sine inverse of all of that, so that's what I put in the calculator. Approximately it's 6 degrees. Now the 6 degrees is that blue little thing that I've labeled. The actual course would be 120 plus the 6 degrees that the wind actually blew it off course. So the course is heading of 126 degrees from due north. Clockwise direction. If you want to be very specific.